Okay. So now we are going to consider a common emitter amplifier, and we are going to find short circuit gain. We are going to find what will happen if the load is short circuited. You can see here in the load side, I'm not going to have RL, I'm going to have simply a wire. I'm going to short circuit my load. So if I short circuit my load, in this diagram you see, already you have one resistance RCE here, right? So RCE parallel to 0. What is RCE parallel to 0? What is anything parallel to short circuit? What is the effect if you short circuit a resistance? Here you have RCE. Here I am going to have a short circuit. What is the effect of RCE parallel to short circuit? What is the effect of RCE parallel to short circuit? What is the effect? If any resistance you are having parallel to short circuit, what is the effect? See, these things you should be taught in basic electrical engineering. What happens when you are short circuiting? What happens if you are open circuiting?
Voltage drop will be zero, sir.
Hmm?
Voltage drop across the resistor will become zero.
No, will this resistance exist? What is RCE parallel to 0? What is the
Well, it's the same as not having a resistance.
yes, so I can remove this RCE, right? So if I consider a short circuited load, this RCE can be removed. And see here, this capacitance, one end is connected to B dash, another end is connected to ground. So this CB dash C will come parallel to CB dash E. Okay, and this RB dash, and see this resistance RB dash C is I'm going to neglect that because this value is going to be very large. We have seen RB dash C value is very large, 4 mega ohm. So I'm going to neglect that. So the simplified diagram you see, this will be the simplified diagram. You on the output side you will have a current source parallel to a short circuit. That's all. In the input side you will have RBB dash and RB dash C as usual. And you have these two capacitance in parallel, CB dash E and CB dash C. When you have capacitance in parallel, you can add them. So I'm going to replace them by single capacitance CB dash E plus CB dash C. Is this simplification clear to everyone? This I'm doing it for short circuit current gain, to find my short circuit current gain. Anybody is having doubt in the circuit diagram simplification? We are removing RC because RC is parallel to short circuit. We are not considering RB dash C, this resistance, because this value is very high. And automatically the CB dash C will come parallel to CB dash E. So when capacitance is in parallel, you can just add them. So if I make all these simplification, I get this circuit diagram. Okay, so I am marking the input current is II, the output current, load current is IL, and this voltage across your RB dash E is VB dash E. So the transistor's high frequency capability can be known only if you find this function, this short circuit current gain. So this computing the short circuit current gain will help you to assess the gain of the amplifier at very high frequencies. Why we are short circuiting is that is your maximum gain. Because in open circuit current will not flow, so I cannot find the output current, right? So only in open short circuit maximum current will be flowing, so that will lead to maximum gain. Okay, so RL is short circuited. So I once again repeat the steps. RL is short circuited, so RCE will be neglected. Effect of RCE will be 0, and RB dash C I'm neglecting because the value is very high, close to 4 mega ohms, and the two capacitance will become parallel. So I'm going to add them and represent by a single capacitance CB dash E plus CB dash C. Okay, this is the circuit for which we are going to find the short circuit current gain. So you know the short circuit current gain, generally current gain is given by output current by input current. The output current is IL, input current is IA. So you can write AI equal to IL by II.